We'll start by seeing how a translation of a graph is reflected in the expression of the function. Remember, by translation, we just mean moving without turning. And we're going to look at two kinds of translations: vertical, up and down, and horizontal, left and right. In order to examine this, rather than look at some complicated graph of some function with a formula, we're just going to look at kind of a simple graph of a function. So suppose this red line, then, is the graph of some function y equals f of x. And we don't know a formula for f, but we can make a simple input-output table for it. We see the point -2, -1. So if the input is -2, the output is -1. We see the point -1, 0. So if the input is -1, the output is 0. If the input is 0, the output is 1. If the input is 1, the output is 2. And then if the input is 3, the output is 4. Right, so here's my basic function. The first thing I'm going to do to this is translate it 2 units upward. So what does that mean? I'm literally going to take that curve, and every point on it, I'm going to move upward by 2 units. Right. Every point on the graph of G is 2 units above the corresponding point on the graph of F, which gives us a new input-output table. For G, when the input is -2, the output is +1. When the input is -1, the output is 2. When the input is 0, the output is 3. When the input is 1, the output is 4. And when the input is 3, the output is 3. What do we see here? Well, look, we see that each of the output values is 2 more for G than it was for F, while the inputs stay the same. So that means, in order to do G to a number, we do F to that number, and then increase the value by 2. That makes sense, right? We're leaving the x values alone, and we're increasing all of the y values by 2. There's nothing special about 2 here. Right? If we'd gone up by 3, we would have added 3. If we wanted to go down, we would just subtract instead. We can write this down as a general principle. An upward translation by C units is represented by adding C outside of the base function. So we added 2 outside of F in order to get our upward translation by 2 units. For a downward translation, we'll just use a negative number for C. In notation, if we have g of x equals f of x plus c, that means the graph of G is the graph of F translated up by C units. Okay, so that's a vertical translation. What about horizontal? I'm going to start again with my graph of F. We're going to let h of x be the function we obtain by translating the graph of F to the right by 3 units. So that means every point on my graph, I'm just going to move it 3 units to the right. So we see every point on the blue graph is 3 units to the right of the corresponding point on the red graph, which again gives us a new input-output table. When the input is 1, the output is -1. When the input is 2, the output is 0. We have 3, 1, 4, 2, and then when the input is 6, the output is 1. We see that each of the new inputs is 3 more than the old input. In other words, the old input is 3 less. Why am I thinking about this from the point of view of the old input? Well, that's what we need to put into F, right? We see, for example, h of 1 is equal to f of negative 2. What we're seeing is h of x is f of x minus 3. Right, why are we subtracting rather than adding, even though we're moving to the right, which is usually the positive direction? Because before we put the number into f, we have to go back to the old input. This is going to be a recurring theme. We have to go from the input of h back to the input of f. So everything we see inside of the function is going to be, in some sense, backwards. So when we're talking about horizontal translations, a translation to the right by c units is represented by subtracting c inside the function. And then, just like downward was negative up, leftward is going to be negative right. For a translation to the left, we'll use a negative value of c. But notice that we're also subtracting. When we subtract a negative number, that looks like adding a positive number. Right? So we'll see something that looks like addition, and we have to remember that that is actually subtracting a negative. For that reason, there are actually 2 different ways we might describe this in notation, and you can remember whichever one is simpler for you. We can think of it as the graph of f of x minus c means the graph of h is the graph of f translated to the right by c units. Or if we'd rather think in terms of addition, we can turn it around and say that the graph of h of x being f of x plus c means the graph of h is the graph of f translated to the left by c units. In the long run, remembering this one is going to be the most helpful. However, some people choose to just remember both of them. So if we're subtracting inside the function, we go to the right. If we're adding inside the function, we go to the left. And some people choose to remember just the one using addition. So adding goes to the left. Adding a negative number goes to the negative left, so to the right. I'm going to give you one of these to try. So given that this is the graph of y equals k of x, sketch the graph of the function L, where L of x is k of x minus 1, and the function M, where M of x is k of x plus 2. Pause the video and try this now. Okay, k of x minus 1, here we're subtracting 1 outside the function, so we're going to translate down by 1. So that means every point on my original graph, I want to move downward by 1 unit, and so I get this graph. As for M, I'm adding 2 inside. Adding 2, that's subtracting negative 2. So I want to translate left by 2. So every point on my original graph, I want to move 2 units to the left. There's my function y equals m of x.